Imagine if, instead of waiting days for a lab test, or even 15 minutes for a rapid test, you could just press a button and know if the air in this room was filled with flu virus. This isn't science fiction. It's the power of nanotechnology and microfluidics. Today, we're breaking down a brilliant piece of research that created a near-automated device that can capture and identify airborne viruses like influenza and SARS in just 120 seconds. So what's the gold standard for detecting something like a specific virus? Often it's a test called an ELISA. It's incredibly specific and sensitive, but it requires multiple washing steps, careful handling by a trained technician, and it can take hours. Now, try to imagine using that to test the air. It's practically impossible. We need something fast, automated, and sensitive enough to find a tiny number of viruses in a huge volume of air. That's the challenge a team of researchers set out to solve. The solution is a marvel of miniaturization, a microfluidic device. Think of it as a tiny, portable laboratory on a chip. Here's the really clever part. Inside this chip, the researchers grew a forest of silicon nanowires. These wires are unbelievably small, and they coated these nanowires with antibodies, the same kind of Y-shaped proteins our immune system uses to latch onto specific viruses. As air is pumped through the chip, any virus particles, like influenza A or SARS, smack into these wires and get caught, specifically binding to their matching antibody. This is where it gets truly brilliant. How do you detect that a virus has been caught? Most optical methods would require adding a dye or something that glows, which adds steps and time. This device does something much more direct. It measures electricity. You see, at the nanoscale, everything has an electrical charge. When a virus binds to an antibody on the wire, it disrupts the local electrical field. This causes tiny, measurable fluctuations in the electrical conductance of the nanowire. The sensor isn't seeing the virus, it's hearing the electrical noise it makes when it lands. This binding event creates a unique electrical signature that confirms target acquired. So, what does this all add up to? Speed. The total assay time is about 2 minutes. Automation. It's nearly automated. Load it, start it, and get a result. Sensitivity. It's sensitive enough to detect clinically relevant levels. This technology opens the door to continuous real-time air quality monitoring for pathogens. Imagine these sensors in hospital waiting rooms, airport terminals, or schools, providing an early warning the moment a dangerous pathogen levels start to rise in the air. Thanks for watching.